Hi, good evening. I hope you guys can hear me. All right, thank you. Um, I'm Don. I'm a parent of two former Math Kangaroo students, and I was a volunteer for Math Kangaroo. Uh, Both of my kids participated in every Math Kangaroo competition before they went off to college. We used to live in a small town in Kansas, and we had to drive to a large city to take the Math Kangaroo competition at first. Then I helped a local gifted teacher to set up a test center in our small town, and that became very popular among the K-12 students. Both my kids benefited tremendously from the Math Kangaroo competitions and training materials. But right now, one of them goes to MIT and another one goes to Harvard University. And before they left for college, I asked both of them what they thought we as parents did right and what we did wrong when they were growing up. I'm not going to talk about what they thought we did wrong. So when I asked them what they thought we did right, I mentioned the math games and the problems in the early years, largely from Math Kangaroo. The math games and the problem solving brought out their curiosity and motivate them to explore more. Also, the Math Kangaroo problems tended to be more lighthearted and more enjoyable for younger kids. The problem solving skills are definitely very valuable. I am actually a professor of economics. Excuse me. Economics, a lot of times, is about problem solving. For example, how do you maximize the profit of your business, given all the prices? Among the students coming through my classes, usually the students double majoring in math and econ have better problem solving skills, usually on top of the class. I was also very fortunate to sit in a few seminars given by Professor Po-Shen at HMMT, some other math, Princeton math competition. I was a parent then, so Professor Po-Shen gave some seminars talking about how to nurture the kids, and I really appreciate it. I very much appreciate the programs both Math Kangaroo and Professor Po-Shen put together for the students today. Next, I'm going to introduce the two co-hosts today. They are Megan Davy and Kevin Song. Megan enjoys participating in math competitions, both locally and nationally. She represented Nevada at Math Counts Nationals and has qualified for Math Prize for Girls. She also is president of her school's math club and very active in the local math club, including being on the competition team and volunteering over 100 hours per year. She also plays violin and speaks Spanish. The second host is Kevin Song. Kevin represents Wisconsin at the 2019 Math Counts Nationals. He has qualified for Amy since his 8th grade and earned USA CO silver. Outside of math, Kevin is also a varsity volleyball player. He enjoys playing piano and listening to Blackpink. Thank you for the opportunity, and the floor is yours. Thank you.
Okay, awesome. We are super excited to be here. Math Kangaroo is really a great competition. And so it seems like a lot of you guys have noticed this, but if you are sending messages to Chat Relay, then they will appear right down here. For example, we've got someone saying hi, and they appear right here. So if you guys do that throughout this meeting, we'll be able to see your thoughts. You guys can help us solve these questions, and it's just really a lot of fun. And how do stars work? Yes, okay. If you give a really good comment, then some of our moderators are here to give you a star. So just a little cosmetic thing that shows up and says, wow, you gave a good comment. And those will rack up. I think it's 10 minutes that they last, and then they reset. So you can get stars for giving good comments, but we'd also have moderators, so if you're giving bad comments or spammy comments, those will not show up. So be forewarned. We want this to be a fun experience for everyone. And unless there are other questions, I think we will begin with the first question. So basically, for those of you who don't know, the format for today is we have been given a bunch of questions from a 2022 Math Kangaroo grades 5 to 6 problem set. Now, we have not seen them, so we are going to be solving them live for you guys to see. And of course, you guys are more than welcome to see stuff and send stuff in chat that we will see. And with that, let's get started with this first question. You guys should be able to see it on my screen right here. And it just says, Eileen rowed around 5 buoys as shown. Which buoys did Eileen row around in a counterclockwise direction? And so remember, counterclockwise is going to be when you are going like this, against the way that a clock is going. And so I think the easiest way to do this is just going to be to trace out the path. So we start this way, and around 1, we have gone counterclockwise. You can see that when we go like this, counterclockwise, so let's make a note of that. 1 works. And then we come down here and go around 2. This isn't counterclockwise, this is clockwise, so not 2. Then we come back up here, around 3. That seems counterclockwise to me, which these guys are agreeing with. And then, yeah, okay, most of you guys are saying 1 and 3, but let's double check 4 and 5 just to be safe. So, for 4, yep, this looks clockwise, and same for 5. So yeah, great job. 1 and 3 is our answer, E, and if we go check that, that's the answer. So yeah, awesome. Kevin, you want to take the next one?
Sure. All right. Let's go to the next question. So here we have marbles sold in packages of 5, 10, and 25. Tom bought exactly 95 marbles. So what is the minimum number of packages he could have bought? Okay, so this seems really similar to like if you were getting change from a cashier, right? Because you have 5 for a nickel, 10 for a dime, and 25 for a quarter. So we can do what we call a greedy approach, which is where we take the maximum number that we can currently get. So if we start out at 95, then, well, we can have of 25.
Could you elaborate a little bit on what the greedy approach is?
Okay, so
because if you just get the maximum number, I could get the maximum number of packages of 5, but I don't think that would necessarily get us the answer we're looking for.
Oh, sorry, I meant like the maximum number here. Like if you, for example, if you had 30, then you would choose 25 first. But if you had, for example, 24, well, you can't pick the 25, right? So you pick the next largest one, which is 10. Sorry, it wasn't clear enough on that. But okay, so now we have 95. So, well, the biggest one we can choose is 25. So we can take a 25. And that gives us, let me change up a color. That gives us 75 left. No, that does not give us 75. That gives us 70 left. My bad. Then we can take another 25, and that's going to give us 45. And then we can take another 25, and that gives us 20. Well, once we arrive at 20, we see that we can't pick the 25 package, so we can only pick the 10. So, well, obviously now we can pick the 10 2 times, right? So we do 10, and then we're left with 10 again. And then we pick 10 again, and therefore we're left with 0. So how many packages did we choose? We chose a 25, so that's 1. Another 25, so that's 2. A third 25, so that's 3. And then 2 10s, so that gives us 5. which, as everyone's been saying, is indeed choice B. So nice job.
Yeah. Yeah, you're definitely right. We've got a very active chat today, which is great. Glad to see you guys solving the problems along with us. And solving them correctly, too, at that. Very good. Well, let's go look at this next problem. So, Badiou rearranges the 7 pieces shown to get the smallest possible 12-digit number. What are the last 3 digits of this number? Okay, so when we are trying to get the smallest number, that means we want to minimize the digits starting from the ones with the highest value. So that means that we want to make the, what would that be? 12. So you have hundreds of thousands, hundreds of millions, hundreds of billions, I think. But yeah, basically you have the biggest one is the smallest. So our smallest leading digit is 1 from 113. So we go 1, 1, 3. Oh shoot, that's getting covered by you guys, isn't it? Okay, there we go. 1, 1, 3, and then I look for the next smallest. I think that's a 4. Then, okay, given the choice between, because you see next smallest digits are 5, 1, and 5. So we could either do 515 or 551, and 515 is the smaller option there. So 515, and then what's next? Right, okay. We have 2 of 6, so 6, 7, 6, 9, and then 9. And just double check, that uses 1, 2, 3, 1, 2, 3, 1, 2, 3, all of ours. So yeah, just like you guys are saying, this is giving 6, 6, 9, which is option A. And yeah, I think this is what Disha said. We are ordering it with the smallest numbers over here, and if we work all the way over, we get our final answer, 669. And we just double check that right here. Okay, awesome job.
Okay. Let's go into the next problem. So we have Clara starts with 12 and follows the arrows below. Using the rules shown in the picture, what number will she finish with? So here we have, if we go up, that's you divide by 1, or divide by 4, sorry. If you go over, that's divide by 2. Go down, to multiply by 4, and go right, that's multiply by 2. So there are a few ways to solve this. One way is the brute force approach, where we just go through all of these arrows and we can figure out what the final answer is. But that's a lot of arrows, right? That's like 10. And I'm lazy, so I don't want to do that. So another approach we can do is we can cancel terms. So if you notice closely here, if you go down, that's multiplying by 4. If you go up, that's dividing by 4. So if you go up and then down, well, then you divide by 4, then multiply by 4. So that just gives you 1. And then same thing, if you go right, that multiply by 2. If you go left, you divide by 2. So then that's another 1. So essentially, if you make a full square, you just go back to where you started. So what do we have here? We start at the top right corner in a square. We start like here on the square, and then we go down, we go over, blah, 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 so many things. And then finally we go back up again. But what do we have to do to go back to where we started? All we have to do is go right. So, well, what is the right operation? That's multiplying by 2. But if we want to go right, that means in order to flip that around, we have to go left. So that's dividing by 2. So if we start by 12, we just do 12 over 2, which gives us 6, which is choice B again. Let's jump.
Yeah, and yeah, this is basically just the, okay, well, let's go over it a little bit more then. So you'll notice that anytime you go right, we go to double that. But anytime we go to the left, we half it. So if we take, for example, this instance of going to the right, and in this instance of going to the left, they cancel out. This time that we go down, because up and down is times 4, up is divided by 4, so this up and this down cancel, and we can get similar pairs here, here, and so on. So we could think of this simply as if we take 12 and go to the left, what do we get? Well, that is 12 divided by 2, which is 6. We could also think of it as, since these are canceling each other out, any full loop is going to always bring us back to the same thing, because we are going to end up going up the same amount as we go down, going right the same amount as we go left. So we could also say that we are just missing one arrow to the right to make a full loop. So then we are looking for what number do we double to get 12? And that is just what division is. What number do we double to get 12 is the same as if we take 12 and divide it by 2, what do we get? Which is 6. And of course, if all of this isn't something that you see immediately during the contest, there is another very easy way to do this, which is to just simply work out the numbers. So I don't know if I want to do all of this, but you just follow each operation. 12 times 4, 48. 48 times 2, 96. 96 times 4, oh my goodness, that is 384 divided by 2 is going to be 192. And this is going to continue on, not in a very pleasant way by any means. Like, what is this next number? 768. I don't know anyone who particularly likes dealing with numbers of this magnitude, but it's certainly a way. So yeah, even if you don't see that the arrows cancel out, you can just write this out. One cool thing, we're working exclusively in powers of 2, so you could think of this in terms of just the powers of 2, keep track of it that way, but again, this is definitely the bashier option of the solutions, so I would definitely prefer to, just cancel everything out, because that is going to get us the correct answer that you guys are talking about before, which is 6. So hopefully that clears that up a little bit more. Okay, awesome. So, the picture shows a piece of transparent paper with the design drawn on it. The paper is then folded twice as shown. What will be seen on the folded paper? Okay. So, I think we can definitely just take a straightforward approach to this, right? So I think, unless I'm mistaken, because of this paper being transparent, it won't matter which of the folds we do first. So I can just start, I think I'm going to start with this one right here. So we can just transcribe these lines. If we take the long diagonal and flip it over, that's going to look like this, and then 1, 2, 3, shade it. And one easy way to make sure that you aren't getting confused with which way the diagonals are is to think of it all in terms of the center. So the center of our square, it's not going to change whether a line goes to the center or not. So here, we know that our diagonal does not intersect the center, and neither does this one. So that would just retrace the center, and then we have a square, and we are shading the triangle that is on the horizontal, on the vertical line. So it meets at this point. When we fold it over, it goes to this point. So if we shade in here, then that should be our final answer. So we're looking for a diagram that has out of this. So we have the line, we've shaded here, and we've shaded here. And that looks like, okay. Oh, what is the difference between A and C? Oh, okay, yeah, so these are actually shaded differently. So I don't know if you guys can tell this, but A has shadings going like this on both of them, and C has shadings like this on one and like this on another. So that's something we should be keeping in mind here. So, okay. So, oh, okay, because I think we might have actually not remembered to follow our rule fully, because here, actually, this shaded triangle is over here with shadings going towards this point, which corresponds to this point. So that gets shaded like this. And this one had shadings going towards here, which you guys can't see that, can you? Basically, that is going to be this point and this point. So that's going to give us the two sets of shaded like this, which is going to be A. Let me check that. Yeah. Okay. So it looks like we still got some confusion, so let's take this a little bit bigger. So I'm just going to move this a little bit out of the way, and I'm going to get us a nice big diagram to work with. So, okay, I'm gonna hide all of you guys real quick. Don't worry, I can still see you, but we're gonna take you guys away for just a second so that everyone can see this big square we're going to be working with. So, we've got our square. It's divided into 4 parts, and we have here and here, and we've got, and it's important to keep in mind which way our shading is going. So our shading for this triangle, that's not the right button, is going to go like this, and our shading up here goes like this. Okay, so when we do this fold over here, this point right here stays the same, and this one moves over here. And those define this diagonal that we've got right there. So we use that information and draw this line. We have a square that has opposite corners here and here, and so we draw that over here, here, and here, because those correspond to the midpoint of our diagonal and this opposite corner. We draw the line that is parallel to our first diagonal, and our shadings is perpendicular to both of those. So that's like this. And so we can see already that that is restricting us to A, B, or C. So now we're going to deal with folding this part down. So this diagonal right here corresponds to this diagonal, because the top part goes down and this point stays the same. So the diagonal gets folded over. Then our square is going to have one vertex at the center and an opposite one on our diagonal. So that's a square that looks like this. Well, it's not a very good square, but yes. There we go. Good enough. And we have a triangle going from up here with a point here and this side to down here. Point on the side and still sharing this side. So we're looking at this general triangle. And the question now is, which way do we shade it? So you'll see that we shade it towards this point on the center line, which corresponds to this point. So we are going to shade it like that. And if we look closely, that is the same as option A. So, yeah, check our answer. Does that make a little bit more sense to everybody now? Yes, it was certainly a lot. You have to be very careful with all of the lines, your reflections, but we got the right answer.
All right, nice.
Yes.
All right,
yes.
next.
Oh, they were just asking for chat to come back because I had to hide it to draw the nice big square. Don't worry, I could still see everything I was saying, but now you guys can see it too. How long is the meeting? The meeting lasts for an hour. We are about halfway through that, so 30-ish more minutes, give or take. Nothing is perfect, much less me.
Okay, next problem. So Andrew wants to complete the picture so that each row, column, and set of 4 circles connected by line segments contains the 4 numbers 1, 2, 3, 4. What number should he write in the circle with the question mark? Okay, so first of all, you can see that it's a little bit similar to Sudoku if you ever played that. Let me try to get a bigger diagram so you can see which quads of points are connected. Okay, so let's start it with this 3 and a 2. If we have a 3 and a 2, then we still have to fill in a 1 and a 4 here. Well, we can't really be sure of which one to fill in, so let's just take a guess. Let's guess that this is 4 and this is 1. Okay, then what do we get? Well, we know that since this is similar to Sudoku, we have 1, 2, 3. That means this bottom one must be a 4. And these 4 are connected. So if we have a 4, we still need a 1, 2, and 3. We know that this column and this column already have a 2 in them. So that means this one must be a 2. And then it follows that this one has to be a 3 and this one has to be a 1 because there's a 3 here and a 1 there. Okay, let's continue. So we have 1, 3, 2, which means that this one must be 4. We have a 3, 2, 1. So that must also be a 4. But wait, we can't have 2 4s in a column. Okay, so that means we have to go back here and we might have to switch them. So instead of 4, 1, we'll do 1, 4. So we'll go back. All right, so we put 1 and 4. Let's see if that works. So 4, 3, 2, that gives us a 1. Again, we have a 2 on the second column, the second row and the third row, so this one must be a 2. And we need another 3 and a 4. There's a 3 in the second row, so we must have a 3 in the third row here. And that means that this one is 4. All right, so now we have a 4, 3, and a 2, so that means the next one is a 1. We have a 3, 2, 1, so that means the next one is a 4. Okay, now we have to look at this bottom 4. So we have a 2 and a 1, so these two have to be 3 and a 4. Well, this one can't be a 4 because we have a 4 here, so that means this one has to be 4. And so it follows that this one is a 3, And then, well, we have a 1, 4, and a 3 here, which means that this top one is a 2. But we should just, fill this last one in and then check if everything is correct. So we have a 1, 4, a 2, so this one is a 3. All right, so all the rows have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 1, 4, 2, 3, 4 are the columns, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. These 4 are 1, 2, 3, 4. These 4 are 1, 2, 3, 4. These 4 are 1, 2, 3, 4. And these are 1, 2, 3, 4. So we have gotten our answer. It is choice 2. Again, another B.
Yeah. I do want to draw attention to a comment I saw earlier from, I think it was Julian, saying that we know that it is 2 because that is the only spot where we can put a 2. Not because the only number that can be there is 2, because we know we need to put in 2 more 2's. And we already know we can't put a 2 here, 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 or here. So it either goes here and here, or here and here. But you'll notice if we put a 2 here and here, those both share a line group with these 2's. So the only option for where our 2 other 2's go are here and here. So we don't even have to fill in the rest of the puzzle. And sometimes it won't even be possible to fill in the rest of the puzzle. Here it was, but that's not always the case. But yes, those are 2 great ways that will get us both the same great answer. And of course, if 2 ways get you the same answer, we love to see it. So yes, good job. Having E is so rare. Yeah, you're not wrong. Okay, so next question. Some glasses are stacked on top of each other. A stack of 8 glasses is 42 centimeters high, and a stack of 2 glasses is 18 centimeters high. How high is a stack of 6 glasses? Okay, so we've got a really nice drawing provided for us here, and we can notice that this is actually a combination of 2 parts. So they have 1 full glass and some number of tops of glasses. There's a lot more than that, but I don't want to draw them all. So here we've got 1 full glass and 7 tops of glasses. And here we've got 1 full glass and 1 top of a glass. And we know that these are 18 inches and 42 inches respectively. So if we do some mathematics, we can subtract this equation from this one. So f plus 7t equals 42 minus f plus t equals 18 gives 6t equals 24. T is 4 and f is 14. And we can check this by plugging it back into either equation. So I got f from this equation because 18 minus 4 is 14. If we plug it into here, we'll see that that also satisfies. So we know that these are numbers. Then we just have to see what we need for a stack of 6 glasses. 6 glasses has 5 tops, 1 fewer than 6, and of course 1 full glass. 14 plus 5 times 4, that's 20 plus 14, which is 34. Which, yeah, that's D, exactly what you guys are saying. Is this problem 6th grade? Yes, this is part of the grade 5 to 6 thing. Yeah. Yes. Good work, you guys. Okay. Kevin, anything you want to add?
Nope, I think that was a really nice solution. All right, next problem. We have some locks here. So to unlock this lock, you need a code. And we have 4 hints. So the first hint is one of these digits. So we have a 6, 8, and a 2. One of them is correct and in the right place. We have a 6, a 1, and a 4. One of them is correct but in the wrong place. We have a
This reminds me of a
206.
Wordle.
Yeah, it really
You know
does
the
seem like a
game? Yeah.
Wordle. Math Wordle, maybe.
I
So
think there is
206,
one
two
of
of
those.
Yep. Okay, so 206, two of them are correct, but both of them are in the wrong place. And then finally we have a 738, and all of them are wrong. So I don't really see a easy way we can start with the first three, but the last one is very easy. We know that 7 is not one of these, 3 is not one of them, and 8 is not one of them. So we can already cross out choice B. That's not right. All right, so if 8 is incorrect, then that means this 8 is also incorrect. So this is not one of the digits that is in the right place. So either 6 or 2 could be in the right place. But if you think about it, if 6 was in the right place, then here 6 is also in the right place. But then here it doesn't tell us that one of the digits is in the right place. So that means 6 is also not part of the code. 6 is not part of the code. So that means, okay, that's a lot of answers. A is not right, C is not right, and E is not right? Really? I guess we can stop here? The answer is D, I guess. But let's just continue with the hints to see if that's actually right. One of these is correct, but in the wrong place. Well, that's a 4, right? Because the 1 is not here. 4, yeah, that's in the wrong place because it's supposed to be in the middle, but here it's on the right. For this one, 2 of them are correct, but in the wrong place. Well, we have a 2 and a 0. 2 is on the end instead of the front. 0 is at the front instead of the middle. And so that's our answer. D is our answer. 0, 4, 2.
Yeah. This is definitely another one of those questions where, yeah, we can either find the solution or we can just get rid of everything else. Because if you notice hint 2, it says one of the digits is correct but in the wrong place. So if the other two are wrong, then you can only have one of 6, 1, and 4. So it can't be A or C or E. And as Kevin mentioned, you can't have an 8, so it can't be B. So if you notice that, it is pretty quick, but this is also one where you can go through the steps like Kevin did and get the code just to double check, which turned out to be 42. So yes. Yeah, Math Kangaroo really makes some great brain teaser type problems, not just math bashy stuff. It's a lot of fun.
Maybe I can use 0, 4, 2 as my bike lock.
No, but then everyone here would be able to guess it.
Oh yeah, definitely.
Yeah, okay. Oh, this is cool. Anna has a figure shown on the right. Which of the following figures is the same as Anna's? Oh, fun. Okay. So, okay, the first thing that strikes me as important here is that our middle bar, this one right here, it's going up and down, it intersects at the middle of the two other bars. So, using that, we can already eliminate B, because that meets at the edge of one of the bars, and A for meeting over here, and E as well, because of right here. Oh, I don't mean to circle it, I meant to cross it out. Careful what you're writing. Yeah, okay, so like what you guys are saying, C. So yeah, our options
Megan,
are
I think you meant to cross out D, not E, because both of them meet in the middle.
Oh, no, if you look carefully, I'm pretty sure that, so the top one on E, yeah, this one meets in the middle, but at the bottom, this one joins with this one, not this one. you look carefully at the drawing.
Oh,
'cause,
okay.
Yeah.
Yeah.
If
My
you
bad,
see,
my bad.
if this one is at the middle, then you would have a line going out like this instead of
Yeah.
like that. They're definitely careful to see, but yeah. Okay, lots of guys are saying see because it's twisted. Yes, that is exactly correct. So if we look at our two non-central bars, one of them goes like this, one of them goes like this. They are not parallel. I think the technical term is skew, but the important thing to know is that they're not like D where they're both pointing up. So yeah, C. Skew, yeah, so you guys might have heard of parallel lines and intersecting lines. So in 2D space, you can have parallel lines or intersecting lines. Now, in three-dimensional space, you can also have parallel lines or intersecting lines. You can also have lines that just are doing their own thing. They're never going to cross, they're never going to meet, but they're not parallel either. They change in how far away they are from each other. And so when you're working in three-dimensional space, we call those skew lines. They're kind of hard to draw in my two-dimensional thing. Yes, in 3D, you can only have skew lines in 3 dimensions, because in 2 dimensions, either they have a constant distance between them, which is one way you can define parallel lines, or they have a changing distance, and that distance is at some point going to be 0. But in 3 dimensions, that's not necessarily the case. 2D would be perpendicular. No, 2D would be intersecting. Lines, not rays, or line segments. Yeah. So obviously here we are looking at some line segments, but if you look at the, I'm just looking at the direction that they're going. So yeah, because think about it this way. Okay, let me grab a new page. So if have most of you guys heard of parallel lines before? So these are going to be lines that have the same direction. They're both going the same way, but they just start at a different point. And because of that, they're always going to be the same distance from each other. Now, yeah, they are never going to meet. That is true. Now, alternative to that, we have intersecting lines. These are lines that do meet. So, as you can see right here, we've got 2 lines, and they meet. But, yeah, in 3 dimensions, these are not the only 2 options. We can have lines that never meet, but that also aren't going in the same direction. And the reason for that is because you can go like over or under the lines. So like these 2 lines right here, they meet because they're on top of each other. But if you imagine pushing this line back out, right, then they won't ever meet. If you look at 2-dimensionally, they'll intersect, but in the 3-dimensional space, we call it skew. When the 2 lines, they're not the same distance, but they're just never going to intersect. It's a pretty neat, fun word to say. Yeah, it's a really cool concept. I think Kevin has a little diagram of one way you might attempt to show skew lines in 2 dimensions. Again, you can kind of see they kind of intersect in the 2-dimensional thing, but in 3 dimensions you picture them as just like one's down here, one's like up here, and they're never going to meet. So yeah, Kevin, you want to show off your diagram?
Sure, yeah. So if you smash the picture together, then you would get either parallel lines because they're like this, but then if you look in a 3D way, then they're actually not going to intersect at all.
Yeah, and they don't necessarily have to be in parallel planes. They could be Yeah, so you could totally, like, if you think of the two arms that would intersect and you just move one of them backwards. Okay, my arms are very bad at this. If you move one of them backwards, they would remain in the same planes, but they won't intersect. You can also have somewhere it's not quite so obvious that that's what they're doing, that they just look like completely weird, random. They're going so many different ways. Yeah.
Yeah. All right, nice. So I guess this is the last question for today.
Seems like it, yeah.
What? Okay. So which of the following nets cannot be folded into this weird solid? Hmm. I guess we'll just have to go through all of them then, I guess. All right, let's start with A. Do I have a better place to draw? Okay. So for how am I supposed to explain this though?
Well, if we were doing this competition in person, we could maybe do it with um actual paper. But I
Yeah,
think given that we can't do that, what we might want to do is
I
just
can try to
draw
draw it
ourselves.
out.
Yeah, just try to see what it would draw like.
All right. Um, okay. Let me copy them and then see if I can draw it out. So this is gonna take a while.
Yeah.
1, 2, 3, 4, 5, 6, 6, 2, and 2.
Three-dimensional whiteboard. Yeah, one of the characteristics of whiteboards is that they tend to be pretty two-dimensional, which is an unfortunate fact. Which can't work. Yes, that is correct. Which of the following nets cannot be folded into the solid?
Okay, I guess I just accidentally deleted my slide again. What? Oh, time to redraw that.
3D whiteboard on GeoGebra. Yeah, there are definitely tools that can help you with 3D visualization, but I wouldn't necessarily call them whiteboards. And they're most definitely not permissible in Math Kangaroo, whereas what we are doing is a form of writing on a two-dimensional surface, which will be much more applicable to when you guys are trying to solve these problems because you are allowed to write on paper whilst you are not allowed to be using GeoGebra. Whiteboards don't work very well. Well, I will disagree with you, Julian, but you are allowed to be wrong, I have been informed. So, respectful disagreement. Yeah, okay, looks like we're getting a lot of answers coming in. They seem to have a big variety, though. Oh, I see someone talk about the amount of pluses and minuses. One thing to keep in mind here is that some of the pluses and minuses won't be visible on our solid. They could be on the back, they could be hiding from where we're not visible. So yeah, the amount is going to matter less than looking at the ways that everything is fitting together. Yes, thanks to the author for making the slides. Yeah, so Math Kangaroo is the one who wrote these questions. They are from past tests. This is from the 2022 grade 5 to 6 test, in fact. But I think it was our moderators who compiled these slides for us earlier today, and yes, they did a great job of that.
I think I finished the
Kevin,
first drawing finally.
I think one thing we need to be careful of is I think your drawing, your net shows the minuses in a separate way from how they are on there. And that's going to be something to keep careful track of, because if you notice, a plus, if we rotate it 90 degrees, still looks like a plus, but a minus rotated 90 degrees looks like this. And so we want to make sure that we are keeping track of which direction those are going in.
All right, so I hope this is correct. So this is the first one. This is A.
Yeah.
So I guess this will take a lot of imagination. So you have this paper, right? And then you fold it right here. So right where the minus and the plus, right? Minus and the plus sign. So you fold it right here.
Mhm.
So then you get this, right? Because you have a minus, and then a plus. And then that plus is going to be on the side. Also, if you want, you can fold this up. So then it'll be on the bottom of the square, which you cannot see. And then this one to the right, which you also can't see.
Yeah.
But
And
that means we're going to have, it's going to take a long time. But
yeah,
that's
one
okay.
thing to look at instead of just the folds is also to picture how these are joining up with each other. So if you look over here, these will join up with each other and these will join up with each other. And of course we don't really care about the blanks. So yeah, when it's folded. I think I saw a cool explanation here for that it's B because when it's folded all the dashes go the same direction. So that's something interesting to think about. I'm not sure that is correct.
Actually, I know the answer, but like, I think it's B because if you like turn these, if you fold them, then you end up with the pluses in the middle, at least in the
Well,
front side. But then if you rotate it, you'll get minuses, but they won't be in the correct order.
yeah. Well, okay, yeah. So if we do definitely want to look at the folds again. So to keep this pair of two together, we're going to have a fold here, here, and here. That's a little bit bulky on the drawing, so I'm going to get rid of those. But so that means that we'll match up here to here, here to here, and then this will wrap around. But we only really care about the plus that's on its own. So that's this one right here. And yeah. So we want the plus that's on its own that is next to two minuses. So that is these two minuses. And yeah, like people are saying, same directions. This is the same direction as this, and this is the same direction. Yeah, we definitely could, and I'd argue should double check that this is possible with the others real quick. But yeah, I think that is a pretty good reason to say why it's B, because yeah. And yeah, just to be clear, I don't know if you guys can see this clear, but we're asking which of the following nets cannot be folded into the solid. So yeah, you have to make sure that you're reading these questions carefully, because sometimes they might be asking for which can, and sometimes they'll be asking for which cannot. And so you need to be keeping careful track of that. But yeah. Okay. Real quick, why don't we just see if we can explain why these others will work. So for C, what we're going to end up doing is kind of just wrapping these around each other like that. And so you'll see that this ends up like matching up next to all of these. And so we have the minus minus and the plus off to the side. So yeah, that one's good. A we already established was good. D, this gets folded over to here, and then this wraps around up. Again, these are kind of hard to explain just visual-wise. Can we do one more? Unfortunately, like I mentioned, these slides are pre-prepared for us by our moderators, so this is the last question that was prepared for them. When will this be happening again? I know that is on our web. Actually, let me check. No, I wouldn't have access to that. Keep an eye out. I'm pretty certain that they're on Friday evenings. I think they're either every Friday or every other Friday, but I believe you can sign up for notifications for this on our website. Do you have to leave? No, especially because we are going to continue going over this, and we will also keep chatting a little bit longer. Yes. Thank you guys for coming by. Real quick, E is probably something we should go over, but that's pretty quick. Also, if we fold this down over here, we'll see that we get the two like this and two like that. This one folded over, same, but we don't need to worry about that. We have our plus, so E works out nicely. So yeah, that's B. And I think Kevin has some good drawings that have definitely taken a lot more effort than these diagrams. Kevin, you want to show them off?
Sure. Well, I guess I can only explain choice A then. This is choice A, and then the white lines are where you're gonna fold the paper. So here you fold the left one, the bottom one, and the one between the plus and the minus. So you get this. And then you fold the one between the plus and the blank and the minuses, and you get something like this, where you have minus, minus, plus. And then this is behind the first two first two minuses. And then you have vertical lines, well, vertical minuses, I guess. And then finally you fold by the minuses, and then you get like this, which is what we want. So A does work.
Yeah, Kevin has got a great drawing there. Yeah, I think someone mentioned before that these are very visual problems. That is very true. A lot of Math Kangaroo is going to involve you being able to visualize stuff and to draw useful diagrams to help with that. I think we've seen a lot of that today, actually. I see someone has put great in letter by letter, but by the way that this works, new messages enter from the bottom. So in reality, they've just put TAERG, and it's certainly a message of support, if not a slightly dyslexic one. Yes. Visualizing, yeah, the paper definitely helps for the visualization. Though, oh yeah, so some of the messages we mentioned before that our chat is moderated. Also, since you guys have been a very active chat, though, not all messages to make it through, just so you guys can read everything, which means that some of them won't show up. Yes, paper is great. If you don't have paper, being able to write on the air helps a lot. Yeah, during Math Kangaroo, you will have paper. If you guys are following along, you can have paper. What do the stars mean? I did cover this in the game, but we do have new people. The stars basically just mean that our moderators think that you have sent in a great message and they want to reward you, giving you some little brownie points for being awesome. Yes. When does the Math Kangaroo sign up end? I don't think it's for a while. I think the deadline is sooner, though, to register for a site. I would recommend having your parent check out the Math Kangaroo website or your local, the local competition, whoever's hosting that for you, is going to be the one with your deadline. Yes, you should all sign up. It is great. We love brownies here, but unfortunately I cannot send you any. All I can do is give you some stars. Chocolate chip cookies, those are not as good as brownies. Yes, thank you guys for coming. I hope you guys have had fun. To be clear, all of you guys trying to send messages letter by letter, there are so many of you now that I could not even begin to try to piece together your messages. Are you in Australia? Okay, give me 1 second. I have a very funny gag that will totally be worth it. That is not what I need to do. Shoot, how do you do this? Okay. If we go like that. No, okay. If we go, okay, there we go. Yes, I am in Australia.
Oh, that is a good one, Megan.
These are the high budget puns you can expect out of the Math Madness Live Solves. And a Math Kangaroo is great. I'm in Australia. I don't know who asked me to say it again. I don't know what they wanted me to say again anyways, but yes. Thank you guys for coming. I hope you've had fun. Me and Kevin will stick around a little bit longer while I'm upside down because I am in Australia.
Yeah.
I believe some of you guys are saying thank you for coming. I'm glad you guys enjoyed. Keep an eye out for when future ones are coming, and if you want to see more like this, we do also offer classes in a similar style. Kangaroos are in Australia. You are very correct. What states do y'all live in? Australia. Are
Yeah,
you in
Australia is
space?
a
I do not
state.
know where that is. Are you in space? No, I'm in Australia. Yes. I too love being upside down. It is the best thing to ever happen to me.
Yeah, just for those who want to register for future live solves here's the link. live.poshanlow.com/live
Yes, and we
solves.
might be able to get someone to put it into the chat for you guys in the main room, but yes, if not, it's on Kevin's screen. Are you
And
levitating? No, I'm just in Australia. This is how I've always been. Haven't you noticed? Yeah, thank you guys for joining us.
yep, thank you guys. Did one person was asking for cookies, right?
I know someone mentioned chocolate chip cookies, but I think it was just in response to me talking about brownie points and brownies.
Well, I have a lot of chocolate chip cookies. Do you want to
Oh,
see?
you do?
Yeah, yeah. In fact, I have 64 trillion cookies for you.
How much time have you put into that?
I don't spend much time. I just leave it on for a long.
Okay.
Also,
Mhm.
actually nothing.
Cookies are good. I want cookies now. I have brownies. Maybe I should have one for dinner. With dinner. Don't eat dessert for dinner. Eat dessert with dinner. Be responsible, kids. Amogus, no.
Hmm?
But I don't think I ever told anyone this. So, for those of you who don't know, the AMCs are a great math competition for when you get to middle school and high school. And if you are a girl or non-binary, one of the competitions that you can qualify for based off of the AMCs is Math Prize for Girls. It's this really cool competition with a bunch of great girls, and it's hosted at MIT. You have the option to stay with an MIT student for the weekend and just get to see the culture. It's really great. Highly recommend if you guys get in. Highly recommend applying if you guys are eligible. But anyhow, so I went there. I got in really late because flights are a nightmare. I got in at like 2 a.m. And I see that they've put up some Post-its on their window. And I'm like, oh wow, that's cool. They got some decoration. I'll bet it says like something really cool if you are looking through from the other side. Like, I wonder what it says. Just, curiosity. So, as it turns out, I look at it again in the morning, and, well, give me 1 second. Okay, it's a little bit hard to see, but so this is the image. Now, late night me looks at it like this and says, oh, okay, how do I do this? There's an M. Like, okay, let me trace this out for you. There's an M. There's an I. And I'm like, oh, there must be another window off to the side with a T. MIT, That's the university I'm in. It's in a window. You're looking at it backwards. That's just how it works, right? And then I look at it in the morning with fresh eyes, and I realize, no, in fact, that is not what this is. It's an Among Us. Here, let me see if I can make it a little bit clearer.
Thank you. We take those. We take those.
Yes. Okay, good enough. It's beautiful. I am, yes. Very sus, yes, I'm aware. Among Us is superior. You're just factually incorrect, but okay, yes. Yeah, now you guys have to head out. Yes, I hope you guys have a good evening. Hopefully we can see you here again. It's not always going to be us, but it is always going to be some great hosts. They're not all from Australia either, unfortunately.
Yeah, some of us are from Mars.
Mm. From Jupiter. Interesting. Bye. Yeah. So Kevin, what do you think of the problems?
I think they're really good. Actually, I haven't done a math competition in a long time, so that was pretty refreshing for me.
Yeah. I've been doing Math Kangaroo for a while now. They're always really great problems. They're way
Yeah.
different than like the other stuff you'll see, especially as you get older, right? Like, yeah, it's a great drawing. Yeah. One of the other TAs here, who also hosts some of the live streams. I wonder, is he doing anything up and coming? I'm now curious because if he is, I can send you guys to go bug him about this. Let me see. Oh shoot, I don't see a menu thing upcoming. Okay, well, one of our other hosts who was, yeah, they do a lot of great work here, but they are notoriously bad at just drawing anything. Like, I have an image left over from when he was drawing a rectangular prism. So, everyone knows how rectangular prisms work, right? You have the front face, you have the side face, you have 4 sides here, you add on 3 because you already have one, and then for the top face, you just add on 3 again. And then you've got yourself a rectangular prism.
What? What? That's a nice house.
This isn't a joke. Like, this is just legitimately the drawing of a rectangular prism. Kevin, did you not know this?
I did not know that.
Yeah, so Jesse, one of our teachers that we work with here.
Jesse?
Yeah, Jesse. I have it somewhere. Where do I have it? Oh well. But yes, they're top tier god level drawings, and by god level I mean god level in how utterly bad they are. Shoot. How do I find this? Oh well. Yeah. Oh my goodness. You guys do know that we can no longer read the single letter messages, right? And that the other people also can't read them because not all of them get sent through. Are those the Greek letters?
Oh, yeah. One day after class, I just randomly searched up the alphabet and just wrote all of them.
Brownie points, yes. Here, take a brownie point. Chocolate chip cookies. Chocolate chip cookies are great. They're making me hungry. Key lime or pumpkin pie? Definitely key lime. Pumpkin sucks. I don't know why people like it so much.
I agree with you. Key lime.
Yes, Kevin, peak artistry. And I hope we finally get to do a Thanksgiving potluck again. They haven't done it for a while because of COVID, but it was great.
Do you eat turkey?
Yeah, but I don't particularly like it. But tradition.
Yeah, because I heard it did not taste that good.
What do you mean you heard it didn't taste that good?
I don't know. During Thanksgiving, we never eat turkey. We always eat like roast duck or something.
Huh. Yeah, I mean, it's not my favorite holiday food. It's kind of meh, but we make a really good mac and cheese, and that's generally what I eat more of. Tea, no coffee. How about none of either? Hot chocolate. Cake or pie? It depends on the flavor of both. Roast duck. Certainly. Roasty ducky. Kevin, why are you an artist? Like, this isn't fair.
I don't know. I actually don't know because like I took like a few drawing classes when I was like really young, but I didn't really do much. I don't know. In my free time, I sometimes do some drawing. Like last week, I went to school and then I found out I forgot both my laptop and my phone. So I just spent every class period drawing my teachers.
Because you weren't able to mess around on the internet?
Yep. Not able to
Sounds
play my
about
cookie
right.
clicker.
Oh my goodness. Do you like boba? I actually like just recently tried it. It's okay. I don't love it, but it's not terrible. Vanilla
I
or
like the
chocolate
tea
cake.
part. I don't like the boba itself.
See, like the tea part is like okay, and the boba is also like okay. Like, eh. Vanilla or chocolate probably depends on like what it's with. Right, like sometimes you just really want like chocolate on chocolate on chocolate, but like sometimes nah. Boba's okay, tea is okay. Yeah, I not a big fan of tea or coffee. I've been told that's an unpopular opinion to have as a high school senior, but oh well. Who likes ice cream? Everyone who isn't lactose intolerant. Speaking of which, they
Good
should
stuff.
really try to become more tolerant, like SMH.
Can you
Yeah, how do
become
people?
lactose tolerant?
Oh no. I mean, I think there's like lactate or whatever that can help you eat stuff with lactose, but no. What's your favorite book? I do not know. Can you leave? Yes, of course. We were never allowed to hold you hostage, but now we do not have any more math to cover. So, yes, you guys are, of course, free to leave. I am curious how many people are still left in there, though. Yeah, glad you had fun.
Thank you. Bye.
Yeah, no,
What's
there's totally reasons to
cholesterol?
not eat ice cream. What's cholesterol? Kevin!
No, I mean a cholesterol disorder. But
Who's smarter, Maggie or Kevin?
Maggie?
Maggie, like Maggie the teacher?
It's definitely a typo. It's definitely her.
Oh. Um, I mean, they're both very smart.
No, they're talking about you.
Oh! Oh my goodness, shoot. Yeah, my name's... Okay, here, let me write this out in case you guys aren't... That's my name. I got confused because there is actually a Maggie who um, works, um, who would also teach classes with us. I actually taught with her. Was a lot of fun. Who was smarter, me or Kevin, though?
Her. You.
We're both very smart, okay?
Okay.
Also, it depends on what you are looking at particularly. For example, when it comes to drawing smarts, I would argue that Kevin is better because my drawing skills go about this far. It's a beautiful drawing, right?
That's nice. That's nice.
Even do a little bit of coloring. No, I can actually draw slightly better than this, but not much. Needs a face. Epic, thank you very much. Are you an IMO? No. There are actually Did anyone go to IMO? There are people who work with us teaching, hosting live solves, who have been to MOP. We might have some in IMO. I don't remember. We've definitely had some in EGMO, which is the girls subset. Well, not subset. It's basically the all-female version of IMO. I don't know about actual IMO, though. But yes, I definitely am not. Kevin also is not, last time I checked.
Yeah, if you check now, I still have not made it.
Ah, such a pity.
Yeah. Maybe if I time travel to back when I was 2 years old and start doing math again, then maybe I would have a small sliver of a chance, you know.
I know this girl who's like been working on math like since like practically that old. She's one of the moppers, but yeah, no,
Oh
still
wow.
no IMO, and she's about to age out of eligibility, which is tragic.
What is it, Sophie?
Yeah, but Sophie works
Wow.
so hard. Like I'm in awe.
Luke Robitaille moment.
No, don't. Luke Robitaille is something.
Or
Like an
Luke Robitaille
impressive
more like
something.
Luke Robitaille more like Luke Ratatouille.
The stick woman is still there? Yeah, she hasn't gotten bored yet. You have $1. Impressive. I have $2. Actually, I have more than that. Um, but that's irrelevant. It's all going towards college anyways. Does Kevin time travel? Well, I mean, Kevin is very good at traveling into the future. Like, he goes to bed and travels like 8 hours into the future. Sometimes, like, he just waits for a second and then he's traveled 1 second into the future. Like, he's pretty good at that. Traveling back in time is a little bit harder, though. This is my, like, hot take on time travel. Traveling to the future is not that impressive.
Mm, yeah. And I don't like get why you would travel to the future anyway.
Um, no, I think there are reasons, right? Like if you are like terminally ill, but you have strong reason to suspect that there will be a cure in like 20 years, but you'll die in 1 year, if you can do like cuz okay, special like is it special or general? Like relativity stuff means that it is possible for you to experience the passage of like half a year and other people to experience like 20 years. So that
Mhm.
could help you be cured, right?
Yeah, I do
Um,
see that.
but I don't know if it's that applicable for most things. Does Megan time travel or goes Megan? I'm gonna assume does Megan time travel, and the answer is yes at the same rate as Kevin.
Mhm. Although I feel like instead of traveling to the future, wouldn't it just be better to travel to the past and then fix all the mistakes so you wouldn't be ill?
Well, but
Big brain.
I don't know how feasible. I don't know how. Have you seen Back to the Future? You can't really get away with traveling to the past.
I've not seen any of those time travel movies.
Basically, the idea is if you go to the past and change the past, it has um, issues. Does Megan play better than Kevin in music? Does Kevin play music? I mean, I presume he does. I just don't know what he plays.
Yeah, yeah, I play piano.
Piano. Well, he is definitely better at playing the piano than I am, considering I stopped when I was like 7.
What do you play now
Actually,
and
no,
then?
that's not true. I play the violin, but
Oh,
not.
nice.
I don't practice as much as I should.
Neither do I, bro. After getting into high school, it went from like maybe an hour to a day to like I don't know, an hour a week.
Bro, same. Who's smarter? That depends on how you are judging it. And regardless, the answer is probably going to be we don't know. Because, like, okay, I'll let you in on a little secret. You can have a really big IQ and still be not the most smart in terms of life decisions.
Or you could be like really
describes a lot.
smart and then a horrible person, and then that makes you
Yeah.
stupid in like conversations.
Yeah, no, I saw, because a lot of my friends are like really, really smart academically, right? But like you'll see them just talking about like the dumbest stuff, right? Like there was a conspiracy. Okay, have you ever seen Horizon Milk? It's like, at least I think that was the name.
Yeah, it's good. I always drink that.
So, for those of you who don't know, it's milk. Okay, I'm gonna have to get rid of the sad lady now. Ah, shoot. Wait 1 second. Okay. Well, while this is coming up, I would like to just inform you again that this was something from some of the smartest people that I know. So, here you have Horizon Milk. It is a lovely brand of milk with a wonderful logo. Now, if you'll notice right here, now look carefully, you might miss it. There is a cow. And behind this cow, there is a picture of the globe. So, if you think about this, you'll realize that this is actually how Horizon Milk has been broadcasting their plan for world dominance secretly to make us all okay with it, because they are going to take over the world and convert it all into cows. This was a genuine conversation held by these people where they were arguing about the legitimacy of this future for the world.
It's okay. Conspiracy theories are also always good.
No, I'm going to disagree with you there, Kevin. For example, I would like to say that you should all be vaccinated, no matter what conspiracy theories say, because science.
Yes. Well, there's no science of world dominating cows, though, right?
Yeah, well, I mean, cows exist biologically. But yeah, that's about as far as you get. No, okay, my English class is we do this really cool weekly discussion where we just read an article, right? And then we talk about how good it is as writing and how good it is as science. And it always turns into a discussion of how much you can consider something science, right? Like, if you have a conspiracy theory that is not based in science, but it involves a cow, then, and it was like a cow and milk. Well, cows producing milk is an aspect of biology. Biology is a science. World domination involves like human psychology and social sciences. So is that enough to make it a scientific topic? Yeah.
I mean, if you say it like that, then we should just make everything a scientific topic. I mean, how do you even define a scientific topic, though?
Yeah, that's the thing, right? Because, like, the generally accepted premise there is that math is going to fall under our definition of a scientific topic, and that softer sciences are not to be called unscientific. You can put them in the softer science category, but they're not unscientific. So, like, you won't get away with saying that, like, psychology is not a science. And you also can't say math is not a science. So, given that, what is a science and what isn't a science? According to some people, just the more math it is, the more science it is. Which is objectively, I think you can understand from that statement how that's a little bit confusing of a take. Because math is, the more math it is, the more math it is. But
yeah. I mean, I guess they're talking about like if you go from biology to chemistry to physics to math.
Because it's more concrete is the argument, right? But
yeah, exactly.
Yeah. No, it's a really interesting discussion. What is the meaning of life 42? That's a less interesting
I don't
discussion.
even get that. What does 42 even mean?
It's a joke from some book that I have not read, but I know just enough about it to be able to answer very useful questions. Yeah, let me pull up. Okay, so yeah, I don't know. Like, it's a thing of like the question. It's like a question. It's like a joke within the book. Notably, remember, I've not read the book, but the question is like, what is the answer to? Okay, answer to the ultimate question of life, the universe, and everything. And the answer is 42, but apparently the question is just, what is 6 times 9?
What?
Um, because they're working in... No, okay. Okay.
Are they
How about
working
this? If you...
like base 14 or something?
No, okay, look it up. Here, I'll send you the link real quick. Just look at this. So people have looked into this and they're like, wow, it's true in base 13. And if you look in binary, then it has like some meaning, something science, right? But literally the dude just says that he just chose a random number. The exact quote is a completely ordinary number, a number not just divisible by 2, but also 6 and 7. It's the sort of number you could introduce. It's a sort of number that you could, without any fear, introduce to your parents.
It's very weird.
Yeah, but anyhow, if someone asks you what's the meaning of life, then the answer can just be 42. Plus, that was the answer to one of our questions from earlier, remember?
All right, yeah. The bike lock.
Yeah.
Wow. Oh, going back to the milk. The definition of science is the intellectual and practical activity encompassing the systematic study of the structure and behavior of the physical and natural world through observation and experiment. So theoretically,
So what
you
is
could
it science
experiment
then?
with cows dominating the world. That is
Yeah.
some experiment you could do. So I guess it is a science then.
Right? Like, and I feel like you could, like, you know that quintessential thing of, like the English analysis of like, well, what does it mean that the curtains were blue? And then the authors over there like, it means the curtains were blue. You
Oh
could do
yeah.
that as part of science because you could do an experiment on what emotion blue curtains elicit from what percentage of readers and whether there's chemicals commonly used in blue curtains that chemically altered. Like, what isn't science? I mean, obviously, the method of determining, well, not even, as I say, the method of determining the answer to life, universe, and everything wasn't, but I think, like, have you ever heard this? If someone asks you to pick a number between 1 and 10, you're most likely to choose 7.
Huh? Why?
I don't know. Let me find where I go with this. It's out number. Okay, here. I'll send you
Steven.
a
Hmm?
Stack Exchange link on it. I saw a really
Okay.
good video about it somewhere. I don't remember what it was. It might have been this one. Let me see. Okay, yes, I found the video. Okay. Here you go. Yeah, so basically, the explanation given is when you go to pick a random number from 1 to 10, you don't choose 1, because that's the smallest. You don't choose 10, because that's the biggest. You don't choose an even because that's just like too even. It doesn't sound random because it's like double something else.
Yeah.
You don't choose 5 because that's in the middle. And you don't choose okay, you don't choose 9 because it's composite. It's got like too many factors, right? And 3 is like too small to be chosen. So you just choose 7.
Wow.
Now,
Psychology should definitely be a science.
yeah, like it's really cool, but also you chose 5. Well, you're the exception.
I choose Pikachu.
I had a really good pun here not too long ago. Here we go.
Oh, nice. Pikachu, I choose you.
Yeah, so for those of you who don't know, this is choose notation. You use it in combinatorics and counting, and the second half is basically how you would write I choose you. So you might see it as N choose K if we go back to where I can actually write. If you write something like this, then you pronounce it N choose K based off of the top one and the bottom one. So over here, Pikachu, I choose you. It's a very bad pun that only people who like the superior branch of mathematics, combinatorics, will get. If you're a geometry person, you might not understand it, but hey, some people just aren't smart enough to get it.
That's tough.
Do you like geometry, Kevin?
I have liked geometry a little more, I guess, because I'm gonna be teaching my 3rd geometry class.
Yeah, I mean, Professor Lowe is good at making people like geometry, but still, you shouldn't like.
Yeah.
Don't do geometry, kids. There's better choices. Well, yes. Okay. How many of you guys are left in the big room? Like, because I can stay, but also eventually I do need to eat dinner, and my mom is cooking something that smells good, so.
Yeah, I gotta eat dinner too. I ate half of my dinner and then came here. Oh, we are half an hour over. Wow, that's a long time.
Yeah.
I guess we can leave then.
Yeah, probably. Okay. Well, goodbye, y'all.
Bye,
We're
guys.
gonna head out. Of course, check the website to see more of this type of content, and we hope you had fun.
Yep.